Okay. Okay, so today we are going to determine higher common factors using Euclidean algorithm, and maybe we will try to solve one or two problems involving prime and composite numbers for this topic. Okay, so we start with Euclidean algorithm. Okay, Euclidean algorithm is a very efficient method for computing the greatest common divisor. Okay, greatest common divisor known as GCD. Okay, if we want to find the greatest common divisor of any two numbers, two integers, then we use this method, Euclidean algorithm. Okay, the greatest common divisor is also known as the highest common factor. Okay, so greatest common divisor and highest common factor, they are the same values. Okay, so before this, if we wanted to find highest common factor, we use prime factorization, right? We used prime factorization and then we drew the Venn diagram to find the HCF, or we find the common factors and we multiply the common factors. Now there's another way of finding the HCF or GCD, greatest common divisor. Okay, so the algorithm for this method, it is called Euclidean's algorithm. So algorithm means the steps involved in finding your GCF. Okay, so there are 4 steps here. The first step is to divide the larger of the two numbers by the smaller one. Okay, if you have two numbers x and y, if y is the larger, then you divide the larger of the two numbers by the smaller one. That is step number 1. Step number 2, if there is a remainder, then divide it by into the divisor. Okay, if you have something like this, x, y divided by x, and say you get a z here, and say that your remainder here is w. Okay, so your remainder is w. So the y here is known as the dividend. Okay, your x here is the divisor. What is the z? What's the z called? Quotient, and your w here is the remainder. Okay, so the divisor is the number at the outside here. Okay, so number 2, step 2 is if there's a remainder, divide it into the divisor. And then step 3, continue dividing the last divisor by the last remainder until the remainder is 0. So when you reach 0, you can stop. The final divisor is the GCF of the original pair of numbers. Okay, the final divisor is the GCF of the original pair of numbers. Okay, you may not understand this algorithm right now. Okay, we look at some example first and then you will understand it. Okay, so let's look at example 1. Okay, this is a very big number. Okay, I'll come back to that later. Okay, let's look at the first example. Example 1. Okay, find the GCD, greatest common divisor of 12 and 30. We want to find the greatest common divisor of 12 and 30. So first we choose the larger of the two numbers. Which is larger here? 30, right? So 30 is the largest number. So 30 divided by 12. 30 divided by 12. What do you get? 12 times 2 is 24. Is there a remainder?
6.
Remainder is 6. Now the remainder, you put it outside and this divisor goes here. Okay, so 12 divided by 6. 6 times 2 is 12. Now, is there a remainder? No remainder. No remainder, right? So we stop here. And the last divisor, that is your answer. This is your answer. Okay, therefore GCD of 12 and 30 is 6. Can understand?
Yes.
Okay, let's try one more. Okay. Second question. Okay, we are going to find the GCD of 123 and 36. So what do we do now? Which is a bigger
Divide
number?
123.
1, 2, 3
So 123 divided by
divided by
36. What do we get here? How many times does 36 go into 123? 3. 36 times 3 is 108. So do we have a remainder here? Remainder is 15, correct?
Yes.
Remainder is 15. As long as the remainder is not 0, you have to keep on dividing, okay? Now take the remainder now, and now the remainder becomes your divisor. This last divisor goes inside here, right? 36 divided by 15. So how many times
2.
does 15 go into 36?
2.
2. So this is 30. Remainder, 36 minus 30 is 6. We still have a remainder, so we have to continue the division. So now 6 goes here, 15 goes inside. So how 6 times 2 is 12. So 15 minus 12 is 3, correct? So we still continue with the division. Huh? So 3 goes here, 6 goes here. 3 times 2 is 6. Okay, 6 minus 6 is 0. So we have reached 0. We can stop dividing. So the last divisor, which is the last divisor? This is the last divisor, 3. Okay, so that is your answer. So GCD for 123 and 36 is 3. That means the greatest common divisor, greatest. So this is the greatest common divisor for both of these. Okay, 3 only. Can you understand that?
Yes.
Yes, madam. Yes, madam.
Okay. Okay, this is for you to try now, okay? Find the GCD of 524 and 148. Okay, you try first.
How is it?
What's your answer?
2,
4.
madam.
What's your answer?
2.
4.
It's not 2.
4.
4.
4.
Yes, it is 4. Huh? Okay, everybody got that? 4? Did everybody get 4? Okay, you started with 524 divided by 148. That gives you 3. And 148 times 3 is 444. You minus this, you get a remainder of 80. The remainder put outside, the divisor comes inside here. 148 divided by 80 is 1. Okay, so minus 80, you have a remainder of 68. 68 is your remainder, 80 is your divisor goes inside. So 1 minus 68, you have 12. 12 is the remainder. You keep on dividing until you reach 0, okay? So 68 divided by 12 is 5 times 12 is 60. You have a remainder of 8, 12. 8 goes into 12 once, so minus 8 is 4. Okay, so 4 is the remainder. 4 times 2 is 8. Okay, you have reached 0. Once you have reached 0, you stop. So this is your answer. Okay, so GCD of 524 and 148 is equals to 4. Okay, if you don't want to write like this in a long division like this, you can also write it out in sentence like this. How will we write this? 524 divided by 148 is equals to 3 times 148 plus
80.
80, right? So what is the next one? Next line will be
148.
148 divided by 80 equals to 1
1.
times 80 plus 68. Okay, then 80 divided by 68 is equals to 1 times 68 plus 12. This minus this divided by this. Now this divided by this is the remainder. Okay, so the next one will be 60 divided by 12 is equals to 5. 5 times 12 plus 8. Then we have 12 divided by 8 is equals to 1 times 8 plus 4. Then we have 8 divided by 4 is equals to 2 times 4 plus 0. So we have reached 0, so we can stop. So your answer is this. This is your last divisor. Okay, so this is the other way of doing it. If you're not so comfortable with the long division, you want to write like this also, okay. So you can do either way, okay. Is there anyone who doesn't understand, who still doesn't understand this, or who wants to do some more examples? Okay, we're going on to the next example. Okay, this is number 4, okay. So find the GCD of 1,424 and 3,084. Okay, find the GCD of these two numbers. Although the numbers look larger, but they are quite easily done. Okay, so I want you to try this now. Anybody got an answer?
3. I got 3.
You got 3, yeah? How about the others?
4.
4.
Okay, some of you got 3, some of you got 4. So I think there are more people with 4. Huh? Okay, let's try this. Huh? Maybe there's some mistake somewhere. Okay. Okay, so we have two numbers. Although the numbers seem quite large, they can be done quite easily. Okay. So we take the larger of the two numbers, divided by smaller of the two numbers. So 1424 can go into 3084 two times. Okay. So this will give us 2848. If we minus this, we get a remainder of 236. So now the divisor, the last divisor was 1424 divided by the remainder 236. So 236 can enter 1424 6 times. This will give us 1416. You minus that and you get a remainder of 8. Now the last divisor 236 divided by the remainder 8. 8 can go into 236 29 times. This will give you 232. That gives us a remainder of 4. So the last divisor 8 divided by the remainder 4. 4 times 2 8. No more remainder. We stop here. No more remainder. Therefore the last divisor is 4. Okay. Therefore GCD of 14243084 is equals to 4. Okay. See, the numbers are very big, but we have done quite fast. That's quite fast. If you do it like trial and error, it's going to take you much longer. Okay. So this method is quite an efficient method in finding the greatest common divisor, or also known as the highest common factor. So this is another method for you to do that. Okay. Okay. What number was that? What was the last question number?
4.
4, is it? No, not 4. Huh? How many we have done already? How many have we done already?
4.
4. Okay, 5, 6. Okay, first 5 people in the name list do question 5. Okay. Next 5, question 6, and so on. Okay. Okay, so the last 5 person, the name list, you do the last question. So there are 5 questions here. Yeah? So each one do only one question. Anybody any of you get your answer first? Just let me know your answer. I can write it down here. Okay, number 5. Anybody got an answer?
I got it.
Number 5?
Yes.
Number 5 is 6. Okay, number 6. Anybody who has done number 6?
Number
Number 6.
6. Also
Also
6.
6? Okay. Number 7? Number 8?
Number 7 is 2.
Number 7 is 2. 2, correct? Okay, good. Number 7 is 2. Okay. Number 8? Number 9? It's for number 9, eh?
No.
9, right?
Right.
23. Okay. Number 8?
9.
How much? So, which is your answer? Number 8? Okay, so number 1 is correct, eh? Good. Number 2 correct, very good. Number 3 very good. Number 9, eh? Very good. So number 8, what's the answer? Anyone?
1.
So is it? Which is it? Is it 1?
1.
Yes,
One.
did you get 1?
Yeah, 1.
Okay, this is your answer 1. Okay, so correct. So looks like all of you can do this, right? Okay. So we finished with this GCD. Okay, we're still in the same chapter, but we're going to look at other examples. So we have 9 examples just now. So let's do one more here, number 10. A little bit different, this question. Okay, so reduce the fraction 861 over 984 to the lowest term. That means they are asking you to simplify this fraction. Okay, so how are you going to simplify this fraction? Normally, what do you do when you simplify a fraction?
Divide.
You divide, right, by a common factor. Okay, so look, if you look at this number, the bottom number, the denominator can be divided by 2. Okay, but the numerator cannot be divided by 2. So you must do trial and error. You must keep on checking the divisibility and find which is the common factor that you can use. Or you can use another method. What method can you use here? Which is the fastest method?
GCD.
Yes, you find the GCD for both these numbers and then you straight away reduce the fraction. So what is the GCD for these two numbers? 984 divided by 861. So how many times does it go into that? 1, right?
1.
So what is the remainder?
1, 2, 3.
123. And then 123. How many times does it go into 861?
7.
7 times. Exactly?
Yes, exactly.
Yeah, so no more remainder. So what is the GCD here?
123.
Yes. So the GCD for 861 and 984 is 7. That means we know that both these numbers can be divided by 7. 7 is the greatest common divisor for both these numbers. So now to reduce this fraction, all we need to do is divide both the numbers by 7. So what do we get here? 861 divided by 7 is 1,
1,
2,
2,
3.
3.
984 divided by 7. Oh, sorry, I made a mistake.
Yeah, wait.
Yes, what's my mistake here? Correct. Sorry. So this is the GCD is 1, 2, 3, not 7. So we are going to divide by. So we are going to divide by 1, 2, 3.
3.
1, 2, 3 is a large number. Okay. If not, if we do 1 by 1, but divide by 2, 3, 4, and it will take us a long time. Okay. So 861 divided by 1, 2, 3 is 7. 984 divided by 1, 2, 3,
8.
8, is it?
Yes.
Yeah,
Yes.
so we have reduced this fraction 861 over 984 to 7 over 8. Okay, that was quite quick, right? Very quickly we have reduced the fraction easily just by finding the GCD. So it makes our work much easier. So if we have a large fraction, to reduce the fraction, all you need to do is find the GCD and divide by that value. Can you understand that?
Yes, miss.
Okay. So that is one of the usefulness of this algorithm, Euclidean algorithm. Okay. Okay, let's try one more example here. Okay. Okay, can you try that? So your first step is to find the GCD. Yeah? So what's your GCD?
$51.
51, yes. So your GCD is 51. So now divide both the numbers with 51. What do you get?
15 over 14.
Yes, 15 over 14. So normally we don't leave our answer like this. We can rewrite it, okay? So we've reduced it easily, okay, by just finding the GCD. So this is the advantage of using the Euclidean algorithm. Firstly, you can use it to find GCD, or also known as HCF, highest common factor. And then you can also use it to reduce any fraction, simplify a fraction, especially if the fraction is large and it's difficult to simplify, then we use this method to simplify the fraction. So, do you understand all that today?